So the first question says, which of the following is a major component of biomass? A. Cellulose, B. Ethanol, C. Natural gas, or D. Oil? So again, 5 seconds. I'm going to pause for 5 seconds, pause the video, and attempt to answer it. Alright, so I'm back. The right answer in this case was which of the following is a component of biomass? Was A. Cellulose. The reason why the other ones are wrong: ethanol is a byproduct, or a product which can be produced, product that can be produced by cellulose, but it itself is not directly biomass. Natural gas is also wrong because it's a fossil fuel, and so is oil. So these are both are fossil fuels, and thereby are not biomass. A was the correct answer. Now this is next one. So cellulose is a linear polymer, which is a structural component of plant cell walls, which is the correct representation of parts of a cellulose polymer. You can have a look at these, even though they're all kind of close together. Hopefully you can still make out which belongs to which. See which one's the right one, and you get 5 seconds. So hopefully you had a crack at this one as well. Now here we have to look at, first what we do is we look at the big carbon chains here, these ones, and see if they're on alternating sides. Remember, they always have to be on alternating sides. Now in this case, for A, they're on top here, they're on top here, so they're not on alternating sides, not on opposite sides. So A is wrong. Same thing with here, with D. They're on the bottom, on the bottom, on the bottom, on the bottom, on the bottom. So D is also wrong because they're not on alternating sides. So we're left with either B or C, which is the correct one. So they're both on alternating sides. We've got one here, and then one here, and one here, and one here. So that's the same for both B and C. But because the actual glucose monomers here are flipped, we're also going to make sure the actual bonds are on opposite sides. And we check the bonds here. This one's a bottom, on the bottom, on the bottom, on the bottom. Whereas here it's bottom, top, bottom, top. Remember, this allows us to make a straight molecule, which is what we want. So this one's wrong because in this case the bonds are all on the same sides. These carbon groups plus the bonds have to be on opposite sides. So B is correct and C is wrong. Again, I'll read it and then 5 seconds to pause the video and try it yourself. Water is released during a polymerization reaction. Which monomer is likely to have been involved in the reaction? A. Ethene, B. Glucose, C. Styrene, D. Vinyl chloride. Alright, so I'll answer the question. So the correct answer was glucose. The reason why ethane is wrong, ethane is usually to do with addition polymers. Addition polymers, there's nothing lost, there's no water molecules lost, only things gained. Same thing with styrene as well. Styrene and vinyl chloride are all examples of addition polymers. And in addition polymers, you have no water being lost, whereas glucose is the example of a condensation polymer. And in a condensation polymer, we usually lose a small water molecule or a small molecule. And in the case of glucose, it's a small water molecule. Again, I'll read it and then you get 5 seconds to pause the video and attempt it yourself. Why is research into synthetic biopolymers attracting great interest? A. They decompose more easily than traditional synthetic biopolymers. B. They can be produced more cheaply than traditional synthetic biopolymers. C. They have superior physical properties compared to synthetic traditional polymers. Or D. They have superior chemical properties compared to traditional synthetic polymers. Alright, so you get 5 seconds. See if you can attempt it yourself. Alright, so the correct answer was A. The reason why both D and C are wrong is because they actually have the same properties, usually, physical and chemical. They are decomposable, that's the big difference, but in terms of physical and chemical properties, they're very similar. They are more expensive than your synthetic ones, so they're definitely not cheaper. So the reason why A is correct is because A It has to do with decomposition, and your biopolymers are usually the ones which decompose more easily. I'll read it again and then you get 5 seconds to answer it. Tyrylene or polyester is a condensation polymer. Part of the structure of the polymer is shown. This part here. What are the two monomers that form this polymer? A, B, C, or D? These two, these two, or these two? Right, 5 seconds to pause and attempt it yourself. Right, with a condensation polymer, what we know is it has to have either OH groups, carboxyl groups, or amine groups. It has to have one of these three. On the functional parts, so the end parts, these end parts here, have to be one of these. So we can see A is already definitely wrong because in this case, this monomer only has hydrogens, it doesn't have one of these. This one might be right, but this one's definitely wrong. Same thing with C. Here we have, again, we only have hydrogens at the end, so that's wrong as well. Now if we look at B and D, they could be right because we have a hydroxyl group here and here, and we have a hydroxyl group here and here, and we have on the other end we've got a carboxyl group here, carboxyl group here, carboxyl group here, and carboxyl group here. So that's correct. But the way we can know that D is correct, because D is actually correct, the way we know D is correct and C is wrong, because it says a condensation polymer. That's when we lose water. So we lose water, and there's no need to have double bond being broken. So here we've got a double bond, whereas in the actual monomers we don't. We have a single bond. So this doesn't actually happen. This is false. It has a single bond, which is like this one here, because the double bonds only get broken for addition polymers, not for condensation polymers. So B is wrong and D is correct. And these will join, the OH groups here will join to form that condensation polymer. The next one, I'll read it again. Glucose, C6H12O6, is a monomer that can form naturally occurring polymers. Approximate atomic weights for the elements which make up glucose are shown in the table. Element, carbon, atomic weight of 12, hydrogen, atomic weight of 1, oxygen, atomic weight of 16. Using data from the table, what will be the approximate molecular weight of a polymer made from 5 glucose monomers? So again, 5 seconds, and then attempt it yourself, and I'll go over the answer. So I'm back, so I've got my calculator here. What I'll do is I'll go over each. What you have to do first, the first step is you have to find out how much one glucose molecule, how much its weight is, and then times by 5. So how do we do that? We've got the atoms here, and we've got the weights here. So we have carbon, which is atomic weight of 12. We've got 6 carbons in one glucose. So what we do is we have 6 times 12. 6 times 12 is at C6, so 72 for carbon. I won't have to use the calculator for hydrogen because it's 1 times how many do you have in one glucose? We've got 12, so 1 times 12. It's 12 for hydrogens. And oxygen is 16. Again, we have 6 oxygens, so we have to do 6 times 16, and that gets us 96. And then what we do is we add all that together. So we do 96 plus 12 plus 72. That's how much 1 mole is, but it asks for 5, so we still have to times that by 5. So 180 is for 1, and times 5 is for 5, and that gives us an answer of 900. So that's 900 is correct. The other ones are all wrong. And the last one, what type of reaction describes the polymerization of glucose into cellulose? Again, you get 5 seconds. So the correct answer is condensation. The reason why the other ones were wrong is addition polymers is where you add something, but you don't lose anything. When it comes to glucose, we make it into cellulose, but we also lose water, so addition is wrong. Hydrolysis means the adding of water. We don't add water, we remove water in condensation. reaction. And substitution is just if you exchange one thing for another. Again, that's not what we're doing. We're just joining them together and losing a water molecule. We're not substituting anything. So those three are wrong, and the correct one answer is D, condensation. So I hope that was useful.